Welcome back to my rubber heart. Today, let's take a step back to the basics and talk about something that every rubber compounder, processor, or engineer has to deal with, even if they don't always call it by name: green strength and green tack. These two properties are absolutely essential in the handling, shaping, and assembly of rubber before it's cured. They might not be the most glamorous topic, but if you don't understand them, or if you ignore them, your compound might look great on paper and fall apart on the factory floor. So what exactly are we talking about when we say green strength? In the rubber world, green refers to uncured rubber. Green strength is the ability of that uncured rubber to hold its shape under stress. It's how well a sheet or profile maintains dimensional stability when you move it from a calendar to a storage rack or from a mill to a mold. It doesn't mean fully elastic or resilient strength like you get in cured rubber. It just means enough mechanical integrity to not slump, tear, or deform during handling. And green tack, on the other hand, is the internal stickiness of the rubber. It's the ability of one layer of rubber to adhere to another without the aid of adhesives or vulcanization. It's what allows tire plies to build up layer by layer and stay in place during curing. It's what keeps your splices closed before molding. It's what makes sheeted stock or extrudate stackable, wrappable, or workable. Now here's the interesting part. Green strength and green tack are not the same, and they don't always come together. You can have a rubber with excellent tack but very low strength, which sticks well but sags or tears under its own weight. Or you might have great green strength but no tack, which means it holds its shape well but won't bond to itself without help. Both properties need to be tuned depending on how you're going to handle the rubber before curing. Now let's talk polymers. Different base rubbers have very different inherent green strength and tack levels. Natural rubber, for example, has excellent green strength due to its long, high molecular weight chains and high entanglement density. It can be calendared, cut, spliced, and handled with minimal sagging or tearing. Its tack is also quite good, especially in high purity, well masticated grades. That's part of why natural rubber is still irreplaceable in many tire and heavy duty applications. Now, take something like EPDM. It's a great outdoor and ozone resistant rubber, but in its green state, it's notoriously soft and flowy. It has low green strength and very little tack. If you are working with EPDM on a calendar or extruder, you need to either handle it very carefully, add tackifiers, or co-process it with a stronger face. Otherwise, it will distort or delaminate before it ever sees a press. Then there is nitrile rubber. It has moderate green strength and tack, but the values can vary a lot depending on acrylonitrile content and plasticizer load. Higher acrylonitrile grades tend to be more rigid and less tacky, while lower ACN content blends give you more softness and better stickiness. You can fine-tune NBR green handling by playing with the oil extension, the filler system, and the processing aids. SBR, or Styrene-Butadiene rubber, sits somewhere in the middle. On its own, SBR is relatively weak in green strength, especially at higher temperatures. It also doesn't have much tack unless plasticizers or tackifiers are added. That is why it's often blended with NR to improve processability in things like thread compounds or mechanical rubber goods. The NR gives green handling and the SBR brings aging resistance and cost control. When we talk about compounding, the picture gets more complex and more interesting. Green strength and tack can be dramatically influenced by the types and levels of fillers you use. Reinforcing fillers like carbon black increase modulus and improve green strength by creating a more structured network within the compound. However, they can reduce tack, especially if the filler loading is high or poorly dispersed. On the other hand, resins and tackifiers can dramatically improve green tack without doing much for green strength. Adding hydrocarbon or rosin ester tackifiers along with processing oils helps the rubber flow slightly and wet adjacent surfaces, increasing adhesion between layers. The cure system can also play a subtle role. Even though the rubber isn't vulcanized yet, Accelerators and pre-curing behavior can influence how the rubber handles. If a compound is scorchy, meaning it starts to cross-link too early, you might notice a sharp increase in green strength at the wrong time, causing lumpy calendering or bumpy extrusions. Conversely, a compound with too long of a scorch delay might remain weak and floppy too long, making it hard to cut, wrap, or laminate during production. Temperature also matters. Green strength and tack are both temperature sensitive. As you raise the temperatures, polymers soften, tack increases, but strength generally decreases. That's why rubber can sag or collapse if left on a hot conveyor or near a warm press. Good compound design needs to balance the ingredients so that the rubber is easy to process at room temperature but stable enough to hold shape until curing begins. These two properties, green strength and green tack, show up at nearly every stage of rubber processing. On the mill, they determine how easily you can cut and fold the sheet. On the calendar, they affect layer buildup and ply alignment. In extrusion, they control how much back pressure and drawdown you can apply before the profile collapses. In molding and autoclaving, they dictate whether parts hold together long enough to fuse into a single cured piece. If you don't have enough green strength, you will get distortion, flow marks, or collapse. If you don't have enough tack, layers won't bond, splice won't hold, and the part may delaminate under pressure. So next time you are tuning a compound for processing or troubleshooting something that looks great in the rheometer but fails in the factory, take a minute to think about green strength and green tack. Are they where they need to be for how you are shaping, assembling, and storing the rubber? Because in the end, curing is only the last step. Everything that happens before that, the calendering, extruding, cutting, wrapping, building, all of it depends on those two quiet properties that make rubber not just a polymer but a processable material. Thanks for tuning into my rubber heart. If you've got questions about how to improve green strength in a soft EPDM or how to increase tack in an SBR blend without making it scorchy, drop them in the comments. And don't forget to like and subscribe if you want more deep dives like this one. See you next time.